Now, the reproducibility is a big issue. Again, I mentioned, when you have aggregation, that's intrinsically a horrible phenomenon. How is it ever going to reproduce? So we set out to figure out what types of stressors would be reproducible, if any, and which would be more stochastic. So, first of all, we make this statement here that a measuring device cannot be used to determine whether a process is deterministic. And that's because the instrument always has its own instrument error distribution, which is a sum of the different errors associated with it. With the Argent, it's temperature, which is actually very well controlled. That's not a big factor, but it's there. You have some width, and then stray light, a reinsertion of a vial, and various other effects all sum up to give that distribution you see there. That's for the Argent. So if you repeat experiments many times and the distribution of the results falls on or within that inherent instrument error distribution, you're operationally deterministic. That's as deterministic as you can tell with that instrument. So on the left-hand side, we're looking again at the normalized molecular weight. It's a function of time. And the lower one is BSA at 58C. The upper one is another monoclonal antibody at 70 degrees C. What you can see is they're very tightly packed for each group. And if we go over on the right-hand side, there the black Gaussian, again, is the inherent instrument distribution. And you look at the results, this is summed up from I think 80 different measurements. And you can see the distribution. It does indeed fall on the width of the instrument. So within the limitations of the instrument, temperature aggregation for both of these proteins is deterministic and reproducible. So it's not random. Now, if we go to the next, on the left-hand side, now this is with contact stir, and we already saw the results with contact stir. It made the solution cloudy, but it was a very small population of large aggregates. What you see is that it really is all over the map. And so it's not reproducible. It's ballpark reproducible, but not highly so. And if you look on the right-hand side, again, the black Gaussian in the center is the instrument, and then the other measurements are spread around it. You can see we're outside the instrument error distribution, so it is not operationally deterministic. It is very much stochastic. And the difference is, remember with temperature, that's a global stressor. It affects every molecule in your solution, whereas stirring is a local stressor. It's just stressing the molecules that are nearby, and that's what's leading to this stochastic result here. Okay, and we could do that for other stressors and other proteins. It gives us a way of determining, is this really a reproducible aggregation phenomenon or is it stochastic?